Assalamu alaikum. You are watching Chem Core with Nadia Tahir. Chromatography is made up of two words, chroma and graphene. Chroma means color and graphene means writing. So chromatography literally means color writing, but it is not merely color writing, it is much more than this. What it is? Let's begin. What is chromatography? Chromatography is a set of physical methods used to separate the components of a mixture. First of all, physical methods, then what's its purpose? Separate the components of mixture. Then continue with the definition based upon their affinities with the two phases, stationary phase and mobile phase. So जो key points हैं, the first one is the physical methods. Chromatography physical methods हैं. इसका purpose क्या है? It separates the components of a mixture. किस बेस पे सेपरेट करती है? बेस्ड अपॉन देयर अफिनिटीज, कि कहाँ सेपरेट करती है? बिटवीन द फेजेस, स्टेशनरी फेज एंड द mobile phase. What is stationary phase? The phase which is static, which does not move, that is stationary phase, and the phase which keep on moving is called mobile phase. Stationary phase can be a solid or it can be a liquid supported on inert solid, while the mobile phase can be a liquid, it can be a gas or plasma or supercritical fluid. अब थोड़ी सी हिस्ट्री देख लेते हैं. माइकल टी स्वेट वाज द रशियन botanist who first used the term chromatography. He used this technique to separate the plant pigments using paper in 903. What was the experiment which T. Sweat performed? Here it is. He take the plant leaves, grinded them, prepared the sample and separated it using the paper chromatography technique. It was his results. Next comes to the principle of chromatography. It is same like that of solvent extraction. Do you remember the principle of solvent extraction? Yes, it's distribution law or partition law. What it is? It states solute distributes itself between two phases in a constant ratio of concentration at constant temperature. मीन्स ये कि जो सोल्यूट है वो टू फेजेस में खुद को कांस्टेंट रेशियो में डिस्ट्रीब्यूट करता है. इट डजंट डिपेंड अपॉन द concentration. The ratio always remain constant. For example, if we have 10 grams of a solute or 10 moles of a solute, let's say it is distributed like 6:4, and if we had 100, it will be distributed like 60 into 60:40. Principle, let's have a look at the types of chromatography. First one is the partition chromatography. It is a type of chromatography in which stationary phase and mobile phase both are liquid. Both are liquid. The second type is adsorption chromatography. In this, stationary phase is solid while the mobile phase is liquid. Third type is the size exclusion chromatography. It has many names. It is also called gel chromatography, gel permeation chromatography, molecular sieve chromatography. What is this? It separates the molecules, it separates the solute based upon size of its particles. Fourth one is the ion exchange chromatography. In this chromatography, we separate the positive and negatively charged compounds, means it's for polar or ionic natured compounds. Fifth one is the affinity chromatography. It separates the solute based upon their affinity with the stationary phase. According to some scientists, there are the four main types of chromatography. Fifth one is not a type, but others say there are five types of chromatography. So I have told you all the five. नेक्स्ट कम्स पेपर क्रोमेटोग्राफी. पेपर क्रोमेटोग्राफी को हम स्टडी कर रहे हैं एज एन एग्जाम्पल ऑफ पार्टीशन क्रोमेटोग्राफी. अब पेपर क्रोमेटोग्राफी पार्टीशन क्रोमेटोग्राफी कैसे है? वी से here the stationary phase is paper. Paper is a solid. It must be the adsorption chromatography. Then why we place it in partition chromatography? Here is the answer. Paper is made up of cellulose which contain 90 to 95% water. So we can say paper is basically water supported on cellulose mesh. So we say one type of stationary phase is liquid supported on inert solid. हमने stationary phase की एक type पढ़ी थी ना कि it may be a solid or liquid supported on inert solid. तो यहाँ पे ये liquid है that is supported on inert solid. That's why paper chromatography is partition chromatography. Is it clear? Paper chromatography has three types. Ascending chromatography, it is like this one here. Mobile phase is at the bottom. Paper is placed in the mobile phase, baseline is not dipped, and solvent ascend, it moves upward. That's why it is called ascending chromatography. It works against gravity. It work against gravity. Upward movement है ना, gravity pulls downward, so it works against gravity. Next type is descending paper chromatography. Downward movement as the name indicate. यहाँ पे क्या होता है, solvent front travels down the length of suspended paper from the top inside the developing chamber. Mobile phase is kept in a trough in the upper chamber. यहाँ पे हमारे पास एक upper chamber होगा. ये it is sealed. It contain the mobile phase. Paper is suspended from this mobile phase tank. Sorry. Solvent front moves downward. As it is moving downward, so it is called descending paper chromatography. Gravity favors it. This is the movement in the direction of gravity. So it takes less time than the ascending paper chromatography, but its setup is difficult and costly. Third type is the radial paper chromatography. It is also called as centrifugal thin layer chromatography or simply centrifugal chromatography. In this we have a paper, circular paper like filter paper we use. Here in the petri dish is the mobile phase. We use a wick of paper or some other material and insert the wick in the center of paper. Wick carries the mobile phase in the center, and from the center mobile phase moves outward radially. Circular फैशन में मोबाइल फेस सेंटर से टुवर्ड्स द एजेस मूव करती है. दैट्स व्हाई इट इज कॉल्ड रेडियल और सेंट्रीफ्यूगल. ये इसका आप रिजल्ट देख सकते हैं. हेयर इट इज. यहाँ पे हमने सेंटर में अगर स्पॉट लगाया है तो इट मूव इन ऑल द डायरेक्शंस. इट हैज नो इफेक्ट ऑफ ग्रेविटी. इट कैन बी यूज्ड also. Next here comes the process of paper chromatography. असेंडिंग पेपर क्रोमेटोग्राफी का ये प्रोसेस है. Here is a sample. Baseline हम लगाएंगे पेपर पे. Then we will take sample 1 drop, let it dry and put it in the jar which was already covered to maintain the equilibrium. We will cover it again. Now we have seen how the separation occur, how spot is converted into its component. Next comes how to draw the results from the chromatogram. Means कि separation हो गई है, हमारे पास chromatogram है, उससे अब हम results किस तरह से calculate करते हैं. That is calculated in the form of RF value. What is RF value? It is also known as retention factor or retardation factor. It is basically the measure of position of the component on chromatographic separation. Means कि जो हमारा chromatogram है उस पे component किस position पे present है, RF value हमें ये बताती है. How to calculate it? It is calculated by dividing the distance traveled by the component by the distance traveled by the solvent. Means के component ने जो distance travel किया है उसे हमने divide कर देना है जो distance travel किया है solvent ने. What we call solvent front. यहाँ देखें, here is the chromatogram. ये सिंगल कंपोनेंट ही लिया हुआ है फॉर सिंप्लिसिटी. ये हमारा स्पॉट था, इट गॉट सेपरेटेड हियर एंड दिस इज द सॉल्वेंट फ्रंट. और भी कंपोनेंट्स होंगे लेकिन हम क्योंकि यहाँ पे एक का ही कैलकुलेट कर रहे हैं तो इसलिए एक कंपोनेंट ही शो किया हुआ है. ए, दिस ए इज द डिस्टेंस ट्रेवल्ड बाय द कंपोनेंट while this B is the distance traveled by the solvent front. तो इन दोनों की जो रेशियो है that is RF. अब एक important point, RF has no units, no dimensions because it is a ratio between similar type of quantities. Sometimes students CM लिख देते हैं इसके आगे, RF के आगे, तो ऐसा नहीं करना. It has no units, it is unitless and dimensionless. लास्ट पे क्रोमेटोग्राफी की एप्लीकेशंस हैं. What are its application? It is used to study the process of fermentation and ripening. Means कि जो प्रोसेस है उसकी कितनी प्रोग्रेस हो गई है ये देखने के लिए हम इसे यूज करते हैं. To check the purity of pharmaceuticals, प्योरिटी चेक करने के लिए. To inspect cosmetics, to detect the adulterants either in food or drinks. In the same way, food scientists or food authorities use the chromatography to detect the contaminants in the drinks and foods. It is also used to examine the reaction mixture in biochemical laboratories. That's all. If you have any questions, you can ask in the comment box. Don't forget to subscribe, like and share. Thank you.